Okay, so one of the next questions was, when we had, let's see, we ground the bottom of that vise, and then what we did was we tipped it up like this, and we clamped it in another vise this way. Actually, it was this vise. We clamped it this way, okay? And so we wanted to make sure that this was clamping square to the back jaw of the vise, right? Because we had an unground surface here. So somebody said, we ended up, I don't know, did we put a piece of paper in there? I don't remember now how we ended up, but we checked it and it was pretty good. We checked it with a cylindrical square this way, okay? And I think we put a piece of paper in there is what we ended up with. That way we could grind this perpendicular with that, okay? And somebody said, hey, why don't you just throw one of Chuck's screwy balls in there? Well, I have a set of Chuck's screwy balls here. I love his little logo there. And Chuck sells these on eBay too. And this is a screwy ball set here. This would probably be appropriate here. One of the problems was that slot was right where we wanted to be, okay? So that's certainly a possibility, okay? But in that particular case, the screwy ball wasn't going to work because of this slot in the middle, right? We probably could have put something there, but then it's another loose piece in there. So we ended up getting it. We just fiddled around with it a little bit. So know this, that when you're working on the grinder and you're doing precision grinding work, everything's fussy, okay? You can't just throw stuff in a vise, tighten it up, and go to town, right? You got to check it, you got to look at it, you got to make sure it's sitting properly. It's a pain in the neck, right? Everything matters, all right? And the closer that you want things, the more it matters, right? Specks of dust, dirty surface plates, dirty gauge bottoms. I mean, everything matters, right? And if you can't repeat what you're doing, then you don't have control of the process, okay? That's your first indicator, right? Is I can't make two the same. Okay, so anyway, that was the screwball question. So let's, so somebody asked about indicators, so let me set up some indicators and we'll talk about indicators a little bit too. Okay, so let's talk about indicators a little bit here. One of the other questions that came up was, when we were putting that the other vise in this vise, somebody said, well, why didn't you just sweep an indicator down this vertical surface, right? Wouldn't that tell you if you were straight in the vise in relation to your granite surface plate? So it's sort of right, okay? And here's the problem though, okay, is, this height gauge, we assume basically that it's straight with the world, right? What I don't know, and I can't prove it, it's not self-proving, is I can't tell you how perpendicular this motion is, this vertical motion that when I go up and down, right? All right, how good that is. Okay, I just can't tell you. Okay, so the resolution of this particular one is 1/1000th of an inch. Okay. That's its resolution, right? So, if we think about it for a second, we'd say, yeah, it needs to be pretty close. So if you measure something down very low and then you go up very high, it needs to be pretty close. But when we're doing grinding work, okay, close takes on a whole new meaning, okay? So now I can't even do it in this situation, but I could mount an indicator sideways here and basically traverse that surface and interrogate that surface vertically using the motion of this height gauge, right? This height gauge. Probably not a good idea. Now, what we ended up using was a cylinder square off of here, right? And the interesting part about a cylinder square is that it's self-proving. Okay, actually, let me drag it out again so you guys can see it. All right. So what we did was we put it on like that, right? Okay, and then we swept across it here and here. Now, when I say self-proving, what I mean by that, in fact, you see me checking it here. You see those numbers on there, right? So if I start at position 1 like that, and I sweep it, then I go to position 2, and I'm just doing quadrants here. I do position 2, and I do position 3, and I do position 4, and go back to 1. All those should read parallel if the bottom of that is perpendicular to that. So that's what I mean that it's self-proving. It's like a cylinder square, right? Somewhere on that is perfectly square, right? And if it is perfectly square, you won't be able to measure any difference between this end and this end, okay, no matter how you rotate that, okay? If you do, that means it's out of square, if you get a variation, okay? And that surface need not be perfectly square either to do that, okay? As long as it doesn't move, you can use some surface that's out too, okay? As long as it's smooth and you're not introducing errors. See, you just go nuts with this, right? So now you're talking about dust and burrs between there, and you just go crazy chasing tents around because they're so small, okay? They're so damn small. So anyway, sweeping that face vertically with an indicator, you would need a special tool like what Stan has, which is that, what is it called? It's called a Square Master, I think, and it has a column that you true up and you check against a master square to calibrate it vertically, right? And it has adjustments because they know that you can't get it perfect, right? So it has adjustments so that you can tune it and reference your master square. Then you can sweep vertical surfaces and do them very quickly and quantitatively too. So you can tell how far something is out of square, okay? So that's a little word about indicators and going vertical, going vertical on indicators. It's kind of a tough thing unless you have a specific tool that does that. And the other type that you can actually traverse vertically is you can use this type here because it has a movement here that kind of is, you can make be vertical, right? But there's no guarantees that all of this is perpendicular, right? There's no way to prove that that thing's moving in a straight line, okay? So that's kind of the problem with doing that. Okay, next thing I want to talk about is cosine error because this comes up on the web all the time. Okay, so the next thing I want to talk about, I see a lot of comments about cosine error, and it's a legitimate effect when you don't have your indicator stylus at a good angle, okay? So let's give a demonstration here of something that's not so good. And somebody commented when we were doing the surface grinding video that we were probably getting erroneous numbers from the indicator. Well, true. We were using it basically to look for high and low and just kind of relative magnitudes, okay, and not so much for exact readings, okay. So many times when you use your test indicator, you're using it as an alignment tool, and the fact that it happens to have numbers on it is kind of meaningless. It could just have divisions or say A, B, C, D, E, F, G for all that matters. You're not actually the numbers. They're not useful in many cases when you're just doing alignment work, okay? You're looking for relative differences, okay? It's high on this end, it's low on that end, things like that. Okay, so, we got this thing set at a pretty good angle, and then we're gonna bend the stylus down a little more so it's even worse. Okay, so that's our angle there. So, let's see, make sure we can all see this here. So what I'm gonna do is I'm gonna lower this down, okay? And I'll lock the fine adjust there, okay? Then I'm going to run this down, and it's hard for me to see it here. I'm using this little height gauge because it makes, I don't have to reframe the shot to get it. All right, so there's a pretty good zero, okay? All right, maybe a little bit off. And then what I'm going to do is I'm going to zero the dial on this as well, okay? All right, let's do that. Okay, I'm zeroed. And now I'm just going to displace this, you know, what the indicator says is 5 thousandths, okay? Let's see, I'm going that way. All right. Oops, let me back up. I went a little past. All right, that's pretty easy to go past here. All right, that's 5 there. Okay. Okay, now what I want to do is I want to show you what the dial says. All right. Hopefully you can see that. Okay. So that's 4.5 thousandths. So with this really crappy angle, okay, it's still only a half a thousandths off over 5 thousandths. Okay. So yes, cosine error is real and it plays a part. Okay, but it's not nearly as severe as people think it is, okay? And that's a crummy indicator angle, okay? And, you know, and that's probably roughly how we had it set when we were checking. So yeah, we said 6 thousandths, it was 5.5, 5, whatever, right? Still pretty close for what we were doing over there, okay? So when people talk about cosine error, right? You can do the math and you can figure it out, or you can be a sheep and just say what everybody else is saying. Oh my God, cosine error. Do the math, figure it out, okay? And then you'll understand that it's really not as much as you might think it is, okay? So that's all. I just want to breathe a little realism back into that, and you know, look at that. I mean, I would never set it up like that if I was taking a real measurement, okay? So, or I was taking a measurement with the indicator itself, okay? All right, anyway, that's enough said about cosine error. I won't be talking about that anymore. All right, so kind of the last question I want to answer that was put up on the video on the vise grinding. You know, a couple guys asked about warming up the spindle. And so the way I want to talk about that is in the terms of a, you know, as a system, okay? So this grinder is a system, okay? And so we have an abrasive wheel, we have a spindle, we have a machine, we have axes that move. So this is a large mechanical system, right? So when you first fire it up, okay, and it's been sitting for a while, it's kind of just that, it's been sitting for a while, so it hasn't reached what I would call an operating equilibrium, right? So after it's been on for a while and things warm up, you know, we're putting energy in here even with this light, right? Okay. As it warms up, there's thermal drift with the whole system, okay? So, and, you know, since there's so many different things going on, that's why we think about it as a system, right? So, and this is true with all machines, right? As they warm up during the day, they change a little bit, okay? I remember a story about a jig bore that they located, I don't know, it was close to a window, and they were doing some precision boring, and you know, in the morning everything was fine. They had set it up and dialed in the tolerances, and they were boring away. And then in the afternoon it started to drift off. Well, it turns out that the sun was coming through that window, and it was landing on the side of the casting, and it warmed it up a few degrees, which changed it, okay? So when we're dealing with very, very small amounts, which this grinder, or pretty much any surface grinder, can deal with, all those things make a difference. So somebody asked the question, hey, don't you warm your spindle up? And the answer is yes, okay? But the way I warm my spindle up is by doing rough grinding, okay? So there's a difference. You got roughing and you got finishing, okay? So those are two distinctly different operations in my mind, because my philosophy is, and the way I learned was you rough ugly, okay? Just remember that, rough ugly. And it's just that, it's rough, okay? The goal is speed and efficiency when you're roughing, okay? And finishing, like a finish carpenter or something like that, is where you get into the details and the finer work, okay? So same thing happens here. So in the case of the vise that we were grinding, that was roughing grinding, okay? We were plowing that thing pretty hard, okay? So nothing like, you know, this thing's plugged into the wall, right? So you're converting electrical energy into heat is what you're doing basically, okay? And noise. So what better way to warm it up than to use it, okay? It's like when you drive your car, right? You can sit in the driveway for 15 minutes letting it get up to operating temperature, or what most manufacturers say nowadays is, you know, just drive slowly for 5 minutes or something like that, or you know, I don't know what they say, 5 or 10 minutes, and before full power operation or whatever, right? Which totally makes sense. Once again, it's a mechanical system that you want to bring up to temperature and equilibrium for it to perform, okay? In the case of that vise, you know, we were roughing and we were putting heat into the system, and we weren't attempting tight tolerances with that initial grind. We were trying to establish some reasonably square surfaces and get it down to a ground finish all over. That way we can go back and do the really fine work and switch wheels and go for fine finishes and tight tolerances, okay? So think of these things as a system, and depending on the tolerances that you're working to, they may need equilibrating to perform at their best, okay? Anyway, guys, if you have any other questions, throw them up in the comments, and I'll try to get to them. And I think it's probably a better way to handle questions in the form of a video. Then that way we can always refer back to them and in context, right? They're not buried in the comments, and other people can access that information. Okay? All right. Hey, thanks for watching, and I got lots of grinding videos coming up. I've been collecting eBay junk that's in need of a regrind. Okay? So we'll get our grind on. Talk to you guys later.